Hello everyone, my name is Ian Crawford-Goss. I am a member of Dr. Brian Lane's Physics Education Research Group here at the University of North Florida. I am going to be giving part of a presentation that is about the work that we did here at UNF the last year, administering a modified CLAS in order to study response shift bias in physics classrooms. So just a brief overview of what this presentation is going to be about. We're going to briefly talk about the CLAS itself. We're going to define what response shift bias is. We're going to explain how we modified the CLAS to study our response shift bias. And then we're going to discuss the emergent phenomenon, the themes that we see in the response shift bias. And we're going to discuss how these themes motivate future work. So the CLAS is an acronym. It stands for the Colorado Learning Attitudes About Science Survey. It is a qualitative survey. It does not test students' understanding of science. It is designed to it's designed for students to self-report their attitudes about science at the beginning of the semester and then again at the end of the semester to see how their attitudes about science, their worldview, their point of view, how that changes over the course of the semester. It is important to understand that the response shift bias idea has been floating around for a while. It is thought to impact the results that we see in the CLAS. Response shift bias is just a fancy way of saying that your self-evaluation criteria have changed from the beginning of a course to the end of a course. So remember, the CLAS is a self-reporting survey. So students take the survey, they report what they think, are prompted to answer certain questions. But your self-evaluation criteria is going to change. Your point of view from the beginning of the semester is going to be different from your point of view at the end of the semester. So we modified the CLAS, hopefully, to study this response shift bias in the results of the CLAS itself. So the way that we did this, the modifications that we made to the survey was we used a two-pass survey method. And basically what that means is at the beginning of the semester, we gave them the traditional CLAS, but we also gave them a second version, where it's like, what do you expect your responses to be at the end of the semester? And then at the end of the semester, we administer the survey a second time. So we give them the traditional CLAS survey, and then we also give them the retro. So like looking back at the beginning of the semester, what do you think your responses were? So beginning of the semester, pre and expected, end of the semester, retro and post. And you can see in the data that we have up here on this slide that there is a noticeable difference, not only between the pre and retro, but also between the expected and the post.
For example, we're going to take a look later at CLAS item Q28 that says, learning physics changes my ideas about how the world works. Well, a student's concept of the world is different by the end of the semester than it was at the beginning of the semester because they have a better idea of what is included in the universe or what is affected by physics. And so their ideas about how they're evaluating themselves there changes. So in order to study response shift bias, we use a retrospective pretest and an expected post-test. In the retrospective pretest in green, the students at the end of the semester are evaluating their beginning of semester responses. So they're saying at the beginning of the semester, I think I gave this response. In the expected post-test, the students at the beginning of the semester are predicting what their end of semester results will be. So the red represents where they expect to be by the end of the semester. And what you notice is if you go from pre to expected, from blue to red, that's their expected shifts at the beginning of the semester, they actually expect to learn a lot on the order of 10 to 20% in each category. On the other hand, at the end of the semester, going from retro to post, the green to the gold, They have believed that they did learn a lot. Again, on the order of 10 to 20% in every single category. So it's the same shift. They believe that they're going to learn a lot, and they believe they did learn a lot, but the floor shifts underneath them. So this difference between pre and retro, this is quantitatively what response shift bias looks like. So we wanted to study where this response shift bias is coming from in the CLAS. So we administered this two-pass survey across 7 physics courses in the spring 2021 semester. We want to acknowledge that this places this study in the middle of the COVID-19 pandemic, and we are extremely grateful to our students for participating in the study in an incredibly stressful time in human history. We had a distribution of courses like you see here on the right, where we have 59% of these responses are from our calculus-based physics sequence, and over a quarter is from either algebra-based physics or intro to astronomy. So it's not solely calc-based physics. As far as student demographics go, we had just over 50%, 54% students identifying as male, 44% as female, 2% as non-binary. In order to study the sources of response shift bias, we added a reflection question after each CLAS statement in the real-world connection category. Why did you give the same answer, or why did you give a different answer for these 2 versions of the survey? And again, we're going to focus our responses here on CLAS item Q28. Once we had these responses collected, we tagged them as a team using an open coding process where we first identified emergent themes and then kind of whittled those down to a core set and then tagged the statements with those themes. We achieved moderate agreement. We're looking to improve this agreement in future iterations of this study. So examining these reflection responses, we found that when students were asked, why did you give the same answer? Why did you give a different answer? They really fell along several themes here. The theme names are pretty self-explanatory. There's definitions here. We want to focus on a few of them based on the frequency with which they occurred in the pre-expected survey and the retro-post survey. First up, let's take a look at the comparison theme. This is where the response compares to concepts or ideas. Not a lot of comparisons going on in the pre to expected. Just under 4% of the responses made an actual comparison of 2 things. But just under 14% made a comparison in the retro to post. We take this to mean that the students are better equipped at the end of the semester to actually make comparative statements, to actually make judgments on their own with regards to their learning. Again, feeding into response shift bias. The next category, conceptual knowledge, occurred with relatively equal frequency, just under 20% in both passes of the survey. This is where the students made any sort of reference to their knowledge of physics concepts. Basically, what this theme comes down to is that the students believe that if they know more about physics, then they're going to feel differently about physics. And we see that this kind of remained unchanged from pre-expected to retro to post. Then let's take a look at the real-world theme. This is any response that references real-world applications of physics. No surprise that this shows up with pretty good frequency because this is the heart of Q28, right? It's my ideas about the real world. Finally, let's take a look at statements tagged with the worldview theme. These are responses that reference the student's perception, engagement, interaction with the world. It also includes declarative or absolute statements. So one we heard frequently was physics is everything all around us. Where the students are making this absolute statement, they're not really justifying it, they're not really saying where they get it from, it's just an absolute that they are presenting. We find that we get fewer worldview statements in retro to post compared with pre to expected, which we also take to mean that the students, again, they're able to sort of make their own judgments. They're not having to rely so much on these absolute declarations. So in the study, we have confirmed the presence of response shift bias in the CLAS. We found that accounting for response shift bias can highlight additional facets of student learning that are hidden in the pre to post, usually static shift. We also identified a few trends to help illuminate student reasoning in how they evaluate their attitudinal shifts. In the future, we'd like to examine these themes more closely by more finely classifying the student responses into sub-themes. We'd also like to examine correlations between the themes once we have more statements tagged and we can establish a better inter-rater agreement. And then we would like to take these themes and use those to generate interview questions to solicit more reflection from the students about their pre and post responses. So thank you so much for watching this presentation. Do please check out our other talks here at AAPT, and we will see you around.